we have to add the square of the odd numbers from 1 to 201. The issue is we have seen expressions like that where they were skipping, like 3 squared plus 6 squared plus 9 squared, but then we could factor out something, and after factoring it was consecutive. That's not an option here. Wouldn't it be much nicer if we were asked the even ones, because then that would be an option? And this is the key to the solution of this problem. How about this one? This is not what we want, but this is the one that we can compute. How much are we off by? If we add all the squares of the integers between 1 and 201, then all the even ones are extra. So let's subtract that, and we can find this, and after factoring, we will be able to find this. So what we're squaring in this second part are the even numbers. Those are 2 times 1 and 2 and 3 and so on. So we can factor out the 2, except this is going to be really 4, right? Because 2 times 100 squared is 2 squared times 100 squared. So after we factored out the 4, this is something we can compute. We're going to compute the sum of the squares of all numbers between 1 and 201, and then we're going to subtract the even ones, which is the same as add the square of the numbers from 1 to 100 times 4. So we're going to use the same old formula. In the first piece, n is 201. So it's n is 201, n plus 1 is 202, 2n plus 1 is 403. And now 4 times, and this one is probably the easiest. We apply it with n equals 100, so n is 100, n plus 1 is 101, and 2n plus 1 is 201. There is another way to solve this problem. Now these are the odd numbers. The odd numbers can be expressed like this. If k is 0, we have 2 times 0 plus 1, that's 1. If k is 1, 2 times 1 is 2 plus 1 is 3. If k is 2, 2 times 2 is 4, plus 1 is 5, and so on. Every time we increase the value of k by 1, this expression would increase its value by 2. That's what we're going to use here. We're going to think of 1 as 2 times 0 plus 1. We're going to think of 3 as 2 times 1 plus 1. We're going to think of 5 as 2 times 2 plus 1. And 201 as 2 times 100 plus 1. Now if we take 2k plus 1 and we square it, we get 4k squared plus 4k plus 1. And so we're going to do that to every single piece. We're going to have 4 times 0 squared plus 4 times 0 plus 1 for this piece. We're going to have 4 times 1 squared plus 4 times 1 plus 1. And for 2 times 2 plus 1 squared, we're going to get 4 times 2 squared plus 4 times 2 plus 1. All the way till 4 times 100 squared plus 4 times 100 plus 1. At this point, you can use really long lines, or you can use summation notation. What I use is sort of a rectangular arrangement. K equals 0 will look like this: 4 times 0 squared plus 4 times 0 plus 1. And then for the next one, I will write it under. So 4 times 1 squared plus 4 times 1 plus 1. And the next one is 4 times 2 squared plus 4 times 2 plus 1. And this is going to keep going until the last piece is going to be 4 times 100 squared plus 4 times 100 plus 1. And now we're going to add column by column. The first column is going to be 4 times 0 squared plus 1 squared plus all the way till 100 squared. This we can handle. Plus 4 times 0 plus 1 plus 2 all the way to 100. Plus, this is a danger spot of this problem, because we would think that it's 100. But we're counting from 0 to 100 and not 1 to 100. So 1 to 100, this 1 plus 1 plus 1, this would be 100. This is 101. And now we can ignore the zeros here. So this is the same as 4 times 1 squared plus 2 squared all the way till 100 squared. So we're going to use the same old formula, where n is 100. So that's n is 100, n plus 1 is 101, and 2n plus 1 is 201. Now, this sum, 1 plus 2 plus 3 plus all of a till n, also has a formula, and that's n times n plus 1 over 2. And n is, again, 100. So that's 100 times 101 over 2 plus 101. At this point, I'm actually tempted to factor out 101. You see all three pieces are divisible by 101. Maybe we shouldn't do it, but let's just... You can just punch in the whole thing in the calculator. Just be careful not to make a mistake. But if we factor out 101, then this piece is going to be 100 times 201 times 4 divided by 6. And I want to cancel a little bit. We can cancel out 2 using 100 and cancel out 3 using 201. Then we would get no denominator, but 4 times 100 becomes 50 because we cancelled out the 2. 101 was factored out, and 201 divided by 3 is 67. That would be the first piece. The second piece, 101 is factored out. This is just 200, right? We can cancel. It's just 2 times 100. All right. So that's 1,373,701. I hope we got the same number using the other technique. Yep. That's always encouraging when you solve a problem in 2 different ways and you get the same answer. Thank you for watching.